Hi there. Okay, let's calculate momentum and impulse by giving this a try. You see I've written the equation in 3 different ways for momentum, and we can add that to our formula sheet too. Okay, and maybe I'll do that right now. So I can also write this as m equals momentum over velocity, or I can write it as velocity equals momentum over mass. Okay, so I have my 2 different ways I can rearrange that equation. So the first one says, give 2 examples of an object with lots of momentum. Okay, what do you come up with? Okay, I'm thinking of a train traveling at 300 miles per hour. Okay, as long as your object is moving, it has momentum. Okay, what about something that has little momentum? Okay, I'm going to come up with a fly. Okay, flying around. Okay, you add your other example. Okay, so question 3 says 2 cars, a Ford, which is 1,000 kilograms, and a Honda Civic, which are 1,500 kilograms, are driving beside each other on the road. If they are both driving with the same speed, which has the higher momentum? Why do you think so? Okay, yeah. Okay, the Honda does. Okay, it has a greater mass, which means more momentum. Okay. So the next 3 questions give you 3 different ways to try and solve using momentum. And I want you to write the equation, plug in the information, and then solve. And I'm sorry, I don't really give you a ton of room to work down, but let's just try and write small. Okay. So the first one says Sam is having a snowball fight with his friend. If he throws the snowball with a momentum of 8.2 kilograms, that's supposed to have a little dot between it, meters per second, and a velocity of 4.1 meters per second. What is the mass of the snowball? Okay, so here I'm trying to find mass. Okay, so I'm going to use which equation? Let's use this one. It has mass by itself. Okay, so mass equals momentum divided by velocity. Okay. So I know what my momentum is. It's 8.2 kilograms meters per second going forward, divided by my velocity, which is 4.1 meters per second, also going forward. And if I look at this, I can cancel the meters per second in the numerator and the denominator. I can cancel the direction because they appear both in the numerator and the denominator. And what am I left with? Right on, 2 kilograms, right? Kilograms is the only unit that's left. Right on, okay? So the mass of the snowball is 2 kilograms. Okay, so I'd like you to try out the other 2 questions yourself, and then I will post the answers for you to check. Okay, turn the page. These ones are about impulse. Again, just a couple questions to get us comfortable with calculating it. Here, the equation for impulse is written 3 different ways, and we can add that to our own equation, our own formula sheet. So I'm going to do that here. So if I wanted to solve using force, I would have impulse divided by my change in time. Or I could also solve for time using impulse divided by force. So it all depends on what variables you're given to determine which question you're going to use. Okay? So here it says a baseball pitcher throws a fastball with 100 ns impulse. If he applied the force in 0.15 seconds, how much force did he apply? Okay, so what are we told here? Okay, well, we don't know our force. Okay, I know my time. And, oh, impulse. Okay, so I know that I equals 100 ns. Okay, so I want the equation that has force first, which should be this one. Okay, so force equals I over T. And when I plug in what I know, my impulse, 100 newtons seconds over time, which is 0.15 seconds. Okay, so my seconds can cancel out. And 100 divided by 0.5 is 666.7 newtons. Okay, so if I were to write a sentence, I would say he applied 666.7 newtons of force to the fastball. Okay, so the other two questions give you an opportunity to try Newton or try impulse looking for a different variable. So give them a try and then check your answer. Right on.